Hello everyone. Let's study the theoretical astrophysics. In this part of these lectures, we are going to study the planet formations. First of all, we'd like to review the planet in a solar system, and the planet outside of the solar system. Planets outside of the solar system are called extrasolar planets. We have studied stellar structure and stellar evolution in the part 2 of this lecture series. We briefly studied the formation of stars in the section 2. During the formation process, a disk composed of gas and small amount of solid particles is also formed. In the section 3 and 4, we studied the evolution and structure of a protoplanetary disk. A disk continues to evolve and settle into a nearly steady state. In the section 5 and 6, we study the motion of a particle in a disk and the planetesimal formations. Solid particles collide and stick together to form larger particles. We consider a planet is formed by a coalescences of planet seeds called planetesimals. Solid planets later formed by collisional growth of planetesimals. We consider terrestrial planet formations in the section 7. If a baby planet called a protoplanet becomes massive, it might hold gas as its atmospheres. When the atmosphere becomes heavy, the gravity of the atmosphere induces the collapse of the atmosphere, resulting in the formation of a gas giant planet. We studied giant planet formation in the last sections. In the first part, we studied solar system planets and the extrasolar planet. In the first subsections, we studied the solar system planet. In the second part, we studied the extrasolar planet. First part is a solar system planet. This is a list of the planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune are names of planets. Second column is a distance from the suns. AU stands for astronomical unit. AU means a mean distance between the sun and the earth. The third column is the mass of the planets. So mass of the Mercury is 3.3 times 10 to 23 kilograms. The last column is the radius of a planet. Mercury has 2400 kilometers. So from this table, you can find the three categories of the planet: terrestrial planet, gas giant planet, the ice giant planet. In the terrestrial planet, you can easily find the Earth is the largest, and the Mercury is the smallest. Especially the Mercury is the smallest among all the planets. In the second category of the gas giant planets, gas giants are much heavier than terrestrial planets. You can easily by comparing the masses of planets. Last one is the ice giant. Ice giants are in the middle. When we discover an object larger than the Pluto, we consider the definition of a planet and determine the definition of a planet in 2006. So this is the definition of planet determined by the IAUs. IAU stands for the International Astronomical Unions. The planet is a celestial body that the first condition is in orbit around the sun. The second condition is has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium nearly round shape. The last condition is has cleared the neighborhood around its orbit. So last condition is introduced to remove the Pluto from the list of the planets. Actually, the Pluto cannot satisfy the last condition of C. So Pluto becomes a dwarf planet in the second category. Dwarf planet is a celestial body that is in the orbit around the Sun is the first condition of A, second condition of B are the same with the definition of the planet. Third condition has not cleared the neighborhood around its orbit. Pluto belongs to the second category, so dwarf planet. And the last condition for the dwarf planet is not a satellite. So all other objects except satellite orbiting the Sun shall be referred to collectively as small solar system bodies. Property of planet. Terrestrial planet, 4 planets: Mercury, Venus, Earth, and Mars. All the terrestrial planet has a core composed of rock and metals. So metal is iron nickel alloy. Terrestrial planet has very small atmospheres. The main composition of the atmosphere of the Earth is nitrogen molecules, as you know. And the Venus, the main composition of the Venus atmosphere is carbon dioxide. Due to the greenhouse effect of the carbon dioxide, the surface temperature of the Venus becomes 500 degrees. So by looking at the neighbor planet, we understand if we increase the carbon dioxide on the Earth, we are really afraid if we end up with the surface temperature conditions with the Venus. So this induced the environmental issues. For the gas giant, Jupiter and Saturn belong to the gas giant planet. A small core composed of rock and metal and ice. Jupiter might have no cores. Heavy envelope of gas and similar composition with the suns. About 75% of the hydrogen and 25% of the helium and a small amount of the heavy element. Uranus and Neptune belong to the ice giant, a core composed of rock, metal, and ice. Low mass hydrogen helium atmospheres. To describe the orbit of the planet, we consider the eccentricity and the inclinations. Eccentricity shows the deviations from the circle of the orbit. So if you draw the ellipse, distance between the center and the position of the Sun is expressed A times E. A is the semi-major axis of the orbit. So this table shows the eccentricity and the inclination of each planet. So by looking at the eccentricity, you can recognize a small value of the E. Small value of the E indicates a nearly circular orbit of all the planets. If you look at the inclination, also the inclination is a really small values. So low value of the inclination indicates that all the planets share the same orbital planes. The Sun and the planets. Mass of the solar system is mainly determined by the mass of the suns. So even if you collect all the masses of the planet, total mass of the planet is about 1,000 times less massive than the mass of the suns. But the angular momentum is related to the rotational motions. If you calculate spinning motions of the suns, you can find the angular momentum of the Sun is 3 times 10 to 48 gram square centimeter per second. If you calculate the angular momentum of only Jupiter's, Jupiter has angular momentum of 2 times 10 to 50 gram square centimeter per second. By comparing the two angular momentums, angular momentum planet is much larger than the angular momentum of the suns. The mass is concentrated at the center, the Sun, center of the solar system. Where the angular momentum is located at the planet, we need to consider the mechanism to transfer mass to the center of the solar system to the Sun. Okay, this is a review of the planets in our solar systems.